Hi, don't we all know and love good old brushed motors? They're cheap, simple, noisy, and still pretty useful. But can we make it behave a little better under variable load without spending money on encoder or any other physical feedback sensors? The answer is sort of. This is a simple experiment that shows how motor current can be used to compensate for speed changes under variable load. The controller monitors the current and increases the PWM cycle when the motor load rises, helping the motor maintain a somewhat stable speed. This is not a true encoder-based speed control loop. It's a lightweight load compensation experiment using only a simple current measurement. The setup is pretty simple. An Arduino Mega drives a single MOSFET which drives the motor with a 10 kHz PWM signal. The current is measured across a 1 ohm low side shunt and it's sampled by ADC of the Arduino. The VFD display shows the current control mode, the duty cycle set point, and the compensated duty cycle, as well as the actual motor current. The motor I'm using in this experiment is a Soviet DPR-42. Its shaft is connected to an identical motor, which I can manually short with this switch to create a very scientific and calibrated load. The system is currently running in open loop mode, as we can see on the VFD as open. So the duty cycle is fixed, and when we increase the load by shorting the secondary motor, the current goes up, and the motor has to emotionally process this new burden by slowing down. And this is how these motors behave in their natural habitat, and this is the behavior we'll try to improve by switching to a compensated mode. In compensated mode, as shown on the VFD as closed loop, the controller treats the rising current as a load increase and adds a duty cycle to encourage the motor to work harder. So when I apply the load, the motor speed stays much closer to the original speed. And you can see the output duty cycle goes pretty much maxed out. It's not magic, and it is definitely not a precision speed control. But for a very simple current feedback experiment like this one, it works better than doing absolutely nothing, which is pretty much proud tradition in brushed motor control. Thank you.